Good day everyone and viewers around the world. Once again, my name is Mr. Victor Aneke, a mathematics and further mathematics teacher in one of the best schools in Port Harcourt, and that's Sleek Angels International School. Today I have an interesting topic in further mathematics that I have to teach you, and the topic is partial fractions. The topic is partial fractions. Our objectives today is to understand the meaning of a compound fraction and partial fractions, and then learn to split a compound fraction into partial fractions and recognize the types of partial fractions. We have about 4 types of partial fractions, and they are linear factors at the denominator, non-linear factors at the denominator, repeated factors at the denominator, and improper fractions. In today's class, we will concentrate first on 2 of the types of partial fractions, and then in our subsequent class we will solve the other 2. So today we will have to first of all learn the meaning of compound and partial fractions. So we have on the board the meaning of compound fraction, and it says a compound fraction is a combination of 2 or more single algebraic fractions. A compound fraction is a combination of 2 or more single algebraic fractions. And then a partial fraction is a process of decomposing a compound fraction into single algebraic fractions. Now, like I said earlier, I have to make you understand the meaning of a compound fraction. So I wrote an example on the board, and I'm going to use this example to get a compound fraction. These are 2 single algebraic fractions. So the question says simplify 3 over x plus 1 plus 4 over x minus 5. Remember, we are trying to obtain a compound fraction. And we said a compound fraction is a combination of 2 or more single algebraic fractions. So I'm going to add these 2 together to get a compound fraction. So if you are with me on this, you know we are going to combine this by finding their LCM. And the LCM of this binomial is the product of both of them in this form. So the LCM of x plus 1 and x minus 5 is their product in separate brackets. So by the time I use this to divide this, I'll be left with an x minus 5. Think of it this way, that this divides this by cancelling this in your mind, and you're going to be left with x minus 5. So x minus 5 times 3 gives 3 in bracket x minus 5. Similarly, this divides this by cancelling this, and I'll be left with x plus 1. So I'm going to have it as 4 times x plus 1, because x plus 1 that's left will multiply the numerator. Of course, you know we are going to expand to get like terms to simplify. So I have 3 times x as 3x, and 3 times 5 as minus 15, plus 4 times x as 4x, plus 4 times 1 is 4, and it's still all over x plus 1 and x minus 5. I have like terms here, and they are 3x and 4x, and minus 15 and plus 4. So I'm going to collect that like terms, or those like terms, and I'll be left with 3x plus 4x minus 15 plus 4 all over x plus 1 and x minus 5. So I can simplify further by adding the 3x and 4x together, and I will have 7x, and then minus 15 plus 4 will give minus 11, and that's all over the x plus 1 and the x minus 5 that formed the denominator. Now this is a compound fraction. because it is the result of the addition of these two single fractions. So one of these is said to be a compound fraction. Now the idea of partial fraction is how I am going to split this compound fraction back to its original single fractions. We say that partial fraction is a process of decomposing a compound fraction into single algebraic fractions. It's a process of breaking down a compound fraction into single algebraic fractions. So my aim in today's class is to make sure that I split this compound fraction back to the original single fractions. And that takes me back to the types of partial fractions we have. We had said we have a linear factor at the denominator. Now if you look at the example we did, it was made up of linear factors at the denominator. We say it is linear because the highest power of the unknown here is an imaginary one, and similarly the highest power of the unknown here is also 1. So this is an example of a linear factor at the denominator. So I'm going to use the decomposition process or the breakdown process to obtain the partial fraction. So we're going to use the decomposition process to split the compound fraction into single algebraic fractions. The question usually comes in this form. It will say split 7x minus 11 all over x plus 1 and x minus 5 into partial fractions. To solve this, or to split this, I am going to write this question in this form. I know that a certain value over the first denominator added another value over the second denominator to obtain the said single compound fraction. Now, to solve or to split this, you write a over the first denominator plus b over the second denominator. Meaning if you had about 3 linear denominators, we would have had plus c over that denominator. But because we have 2 linear denominators in this situation, we wrote a over the first one and b over the second. Our aim is to make sure that a is equal to 3 and b is found to be 4. So in my solving, I must get a as 3 and b as 4. The success of partial fraction depends on the knowledge of the kind of denominator you have in your question. Like in this example, or this question, I have linear denominators. And that is the first type of partial fraction we said here, to recognize the types of partial fraction. And I also said I'm going to teach you how to split a compound fraction into partial fractions. So we are about to split this partial fraction. And having written this as a over x plus 1 and b over x minus 5, I will find the LCM of both of them and solve it as though I have values for a and b. So I have this as x plus 1 and x minus 5. This will divide this like I did in the first instance, and I'm left with x minus 5. I'll have it as a x minus 5 plus this will divide this as well, and I'll be left with x plus 1. Then I'll have b times x plus 1, knowing that when this divides the denominator, the remainder multiplies the numerator. And I'm going to expand this bracket, and I have it as ax minus 5a plus bx plus b over x plus 1 and x minus 5. So a times x gave me ax, a times minus 5 gave me minus 5, and b times x gave me bx, plus b times 1 gave me b. You have to be careful with signs. You have to know that when plus multiplies a minus sign, the answer is minus. So I was careful about multiplying these signs here in order for me to get this answer right. Remember, I must get a as 3 and b as 4. So I'll collect like terms like I did in the first instance. I have ax plus bx minus 5a plus b all over x plus 1 and x minus 5. Recall that it is this compound fraction that is being splitted to single algebraic fractions, and it is this compound fraction that results to this answer here. So I can write here as 7x minus 11 over x plus 1 and x minus 5. Now for the denominators to be the same, it means that the numerators are equivalent. For the denominators to be the same, it means that these numerators are equivalent. So I write it as 7x minus 11 is equivalent to ax plus bx minus 5a plus b. Now I have been able to equate this, and by comparing coefficients, it is believed that a plus b is what brought about the 7x. So 8x plus bx was what brought the 7x. So a plus b is equal to 7. So I write a plus b to be equal to 7. And similarly, minus 5a plus b, the constant values here, bring about the minus 11. So I also write minus 5a plus b is equal to minus 11. I've been able to get two equations, and I'm going to solve them simultaneously to obtain the values of a and b. Remember, a must be equal to 3 and b should be equal to 7. So I come to this section of the board to solve those equations simultaneously. So I just clean this section and then rewrite the question. So I'll have a plus b to be equal to 7 and minus 5a plus b to be equal to minus 11. There are so many methods of solving a simultaneous equation. My preference is to use substitution method to obtain the values of a and b. So I'll make a the subject of formula in equation 1 and substitute in equation 2. And it becomes a is equal to 7 minus b. By the time I substitute that in equation 2, I will have minus 5, open bracket, 7 minus b plus b is equal to minus 11. So minus 5 times 7 will give me a minus 35. Minus 5 times b will give me a plus 5b, and plus b that was originally there to be equal to minus 11. So I take like terms here. 5b plus b will give me a 6b, and minus 11 plus 35 will be equal to 24, plus 24. So by the time I divide through by 6, b becomes equal to 4. b has been found to be 4. I initially said that I was going to find b as 4 and a as 3. I have succeeded in finding b as 4. It is left for me to find the value of a. So I will have a plus 4 to be equal to 7. I am substituting the value of b in any of the equations. I chose equation 1 to get this. So a becomes equal to 7 minus 4, and that's equal to 3. This was a huge success because I just found that a is 3 and b is 4, which was what I said I was going to get from the question. So I have succeeded in splitting the compound fraction into single algebraic fraction. Now, to state the answer, we write it in this form. Therefore, 7x minus 11 over x plus 1 in bracket x minus 5 is equal to, we now write the values of a and b, how we wrote it here, to be able to write the answer in the splitted form. So a was gotten as 3 over x plus 1 plus b was gotten as 4, so it is written as 4 over x minus 5. I have just splitted the compound fraction to the original single algebraic fractions that I started with. The second type of partial fraction is the non-linear factors at the denominator. Non-linear factors at the denominator. Now, if you look at the second question, it says, resolve 7x squared minus 18x minus 7 all over x minus 4, 2x squared minus 6x plus 3 into partial fractions. Look at the nature of this denominator. You can see that one of it here is a linear factor because the highest power of x here is an imaginary one. But this other denominator has 2 as the highest power of the x variable. It means that this compound fraction is made up of a quadratic function as the denominator. Now, it is non-linear. The nature of the denominator determines the success of the split of partial fraction. In order for me to split this, I have to write this question in this form. 7x squared minus 18x minus 7 all over x minus 4 and 2x squared minus 6x plus 3. It will be written in this form. I have a over x minus 4, knowing that a single value was used for a single linear denominator. But in order for me to write the other fraction, I have to write it as the derivative of a quadratic function. I'll take it again. Whenever you have a quadratic function, the numerator is usually written in the form of the derivative of the quadratic function. Because of this quadratic function, instead of writing a b as I wrote in the first example I did, I wrote it as bx plus c. Now, if this quadratic function was given to us as the first denominator here, this numerator would have been written as ax plus b. But because it was the second, we wrote a for the first linear denominator and bx plus c for the second denominator. Knowing that once you're given a question in partial fraction, you have to look closely at the nature of the denominator. If I had 2 quadratic denominators here, this numerator would have been ax plus b, and the second would have been cx plus d. And then the solving will go on as others have. So I have to put the LCM as the product of the different denominators. This will divide this, and I'll be left with 2x squared minus 6x plus 3. Then I write it as a times 2x squared minus 6x plus 3. I'm using the normal addition of fractions, knowing that the LCM divides one of the denominator and you multiply the numerator by what you're left with. So when this divided this in my mind, this cancelled this and I'm left with this. I use this to multiply a. Plus this is also going to divide this. I'll be left with x minus 5. Because in my mind, this cancelled this. So I'll write bx plus c and I'll multiply by x minus 5. The big deal is just to expand this numerator. And I'll expand by multiplying all values that I have outside the bracket by the values or the expressions I have in the bracket. So I'll have this as 2a x squared minus 6ax plus 3a plus bx times x will give me bx squared. Bx times minus 4 will give me minus 4bx plus c times x will give me cx, and then c times minus 4 will give me minus 4c. Remember, it is still going to be all over x minus 4 and 2x squared minus 6x plus 3. Now I have to collect like terms. I have to bring the terms that have x squares together. I'll also bring the terms that have x together and then bring the constant terms together. When I do that, I'm going to get 2ax plus bx squared. And then I'll get minus 6ax minus 4bx plus cx. And then I'll bring the constant terms together, and those are 3a and minus 4c. 3a minus 4c. And they are still all over x minus 4 and 2x squared minus 6x plus 3. Then I'll also have to rewrite this compound fraction to be able to compare coefficients. So I'll write 7x squared minus 18x minus 7 all over x minus 4, 2x squared minus 6x plus 3 to be equal to 2ax squared plus bx squared minus 6ax minus 4bx plus cx plus 3a minus 4c all over x minus 4 and 2x squared minus 6x plus 3. Now if we come back to this section, we have to make sure that there is no sign mistake in this in order to get that right. Now by comparing coefficients, 2ax minus 6a is minus 6ax plus 3a plus bx squared minus 4bx plus cx minus 4c. We have 2a so correct. Now we compare coefficient equal to 7 minus 6a minus 4b plus c to be equal to minus 18 and 3a minus 4c to be equal to minus 7. We compared values that have x squared in them to 7 and values that have x in them to minus 18 and values that were independent of x to be minus 7. So we have three equations here now. I'm going to make any of the variable the subject of the formula in any of the equations to get the other values. So I'll make b subject of the formula in equation 1 So when that happens, b will be equal to 7 minus 2a. b is equal to 7 minus 2a. I will substitute 7 minus 2a in equation 2. And I'll have it as minus 6a minus 4 times 7 minus 2a plus c is equal to minus 18. I have to be careful with signs in order to get this right. I have minus 6a minus 28. I used 4 to multiply 7 to get 28. And I'm also going to use minus 4 to multiply minus 2a to get plus 8a. Then plus c to be equal to minus 18. Then I'm going to collect terms to make it conform to the format of a simultaneous equation. So minus 6a plus 8a plus c is equal to minus 18 plus 28. I moved minus 28 to the right hand side. Minus 6a plus 8a will give 2a, then I'll have plus c. Then minus 18 plus 20 is equal to 10. Minus 18 plus 28 is equal to 10. So I have formed a new equation here, and that's named as equation 4. Then I'll solve equation 3 and the new equation 4 simultaneously. I'll write it on this part as 3a minus 4c to be equal to 7, or minus 7 is this. And then I'll have 2a plus c to be equal to 10. Once again, I'm going to make one of the variables the subject of the formula. My preference is to make c, because the coefficient of c here is 1. It's easier making variables with 1 as their coefficient the subject of the formula. So I'll say make c the subject of formula in 4. That's equation 4. We got this as 3 and we have this as 4. When I do so, c will be equal to 10 minus 2a. I sent 2a to the right hand side and c has been made the subject of the formula. Then I'll substitute in equation 3, and that will be 3a minus 4 times 10 minus 2a to be equal to minus 7. Then I'll open up the brackets. Minus 4 times 10 will give me 40. Minus 4 times minus 2a will give me plus 8a, and that's equal to minus 7. I'll take like terms. 3a will add 8a, and minus 40 will be taken to the right hand side, and it turns plus 40. With this, I have 11a, knowing that 3a plus 8a is 11, and minus 7 plus 40 is equal to 33. Minus 7 plus 40 is equal to 33. Then I'll divide both sides by 11, and my a will be equal to 3. I have found one of the letters that will split this compound fraction into algebraic fractions, into partial algebraic fractions. My next move is to get the value of b and c as well. From this equation, we said that b was equal to 7 minus 2a. So we say substitute into b equal to 7 minus 2a. So b becomes 7 minus 2 times 3, because A is equal to 3. We've substituted A as 3 in the equation. 2 times 3 gives 6, and 7 minus 6 is equal to 1. I've also found the value of B, haven't found the value of A. Now the last of them all is to find the value of C. And the equation in 4 says that C is equal to 10 minus 2A when C was made the subject of the formula. So I'm also going to substitute the value of A, which is 3, into C is equal to 10 minus 2A. To substitute A equal to 3 in C equal to 10 minus 2A. So I have C to be equal to 10 minus 2 times 3. You can agree with me that 2 times 3 is 6. And when 6 is subtracted from 10, I'll get 4. We have succeeded in finding the values of A, B, and C that will be used to split the compound fraction into single algebraic fractions. So I'm just going to clean this section of the board so that I can state the answer. Now that we've gotten A, B, and C to be 3, 1, and 4 respectively, we will then use these answers to split this compound fraction into partial fractions. So the answer will be written in this form: 7x squared minus 18x minus 7 all over x minus 4, 2x squared minus 6x plus 3 to be equal to 3 over x minus 4 plus x plus 4, which represents the bx plus c. Since b is 1 and we don't write 1x, it is written as x plus 4 over 2x squared minus 6x plus 3. We have succeeded in splitting this compound fraction into 2 single algebraic fractions. Now, in today's class, we learned what a compound fraction was. We also learned what splitting compound fraction into partial fraction was. We also learned that the denominator is important in the solution for compound fraction splits. So in our next class, we will learn the other 2 types of partial fractions, which were written as the repeated denominator and the improper fraction. I'm going to leave you with an assignment that will be written on the board and to be submitted to my email address or my WhatsApp number. The assignment is going to be gotten from your new Further Mathematics Project 3, and it will be gotten from page 74 and page 76. The questions are just going to be around the 2 types of partial fractions that we have discussed. So I'm going to clean this section of the board and write down the assignment. The assignments are: resolve the following into partial fraction. So these are the assignments. They were gotten from exercise 5A, page 74, number 1 and number 4, and then page 76, exercise 5B, number 1. These assignments are to be done and sent to my email, which is given as anekevictor16@yahoo.com, and the WhatsApp number, which is 07039371313. Thank you very much.